Greetings, gents. Today we're discussing common password attack types. That those that come to mind often are the brute force attack and the dictionary attack. So the brute force attack basically is that type of attack that targets passwords by trying to generate passwords on the fly and then using these passwords to attempt to access users' accounts. So, how does this generation happen? It starts generating the characters randomly, looking at all possible combinations of passwords that are one character long. When it's exhausted those, it goes to combinations that could be two characters long and then three characters long, and so on and so forth. The limiting factor here, however, is that brute force attacks consume resources, memory, and take time. Because of this, in practice, brute force attacks may be able to generate passwords that could be as long as 6 or 7 characters, but not more. So, how do they work in practice? There is a program in this case, this could be a bot or just a regular program written by a developer that guesses a password, tries to log in with this password to a device. If the guess is correct, they are granted access. If their guess is not correct, then they try another combination of characters, and then the cycle goes on. Another type of attack that is also in this family of attacks, of passwords attacks, is what we call the dictionary attack. Now, the dictionary attack on its own hand uses a list of passwords that you can call candidate passwords that has been precompiled. Precompiled by who? By hackers and other people that operate in the dark world. Now, what these password attacks, attacks do is they take the file that contains the passwords and then they read the passwords line by line. So they read off a password and then they try. If the password does not succeed, they go back and read the next one and then they try. And then they keep doing it that way until the list is exhausted or until a good candidate is found. Chances are that uh, dictionary attacks could take shorter time to achieve the result than brute force attacks. So these are kind of like an optimization if you look at it from that perspective. How do these bad guys get access to these passwords? From time to time, organizations become victims to data breaches, and this data from the organization is leaked. When the data is leaked, someone would export, you know, um, the database that contains hashes, and then they can play with these hashes using rainbow attacks and so on and so forth until they are able to figure out some of the passwords. Once these passwords have been figured out, they get added to the precompiled list. And so over time, the dictionary keeps growing in size. How does the dictionary attack work? The program does a guess and starts at a certain point in the dictionary file. it reads up a line in the dictionary file, which of course should be a password, aims at the target system with this, and checks. The target system now checks if this password is correct. If the password is correct, access is granted. If the password is not correct, the next guess is done by checking maybe the next line or another line randomly taken from within the dictionary file. For in order to optimize the process of breaking into a system successfully, it might be meaningful to randomly pick passwords from the password file. Otherwise, you would have to go through the file from the top to the bottom. Imagine the file where a Word file, for instance, that has 58,000 pages, and your password is on page 57,000. Then the program will have to read through all the passwords from page 1 until it gets to page 57,000. So to optimize, this such a program can use a function that randomly selects a page and a point within the application where a password gets taken. And so the first time it might take a password from page 1, and the next time it takes a password from maybe page 57,000, and then it can go back to page 2 and then go to page 58,000 and keeps going back and forth in a random manner. That way, if your password is actually within this file, then the probability of finding the password is much higher before the program runs out of resources. How do we defend against password related attacks? There's a common number of approaches that we can use. We can actually start by increasing the length of the password beyond 8 characters, for instance. We can also make the password to be complex. By making a password complex, what we're saying is the password now has uppercase letters, lowercase letters, numbers, and special characters put together. We can limit the number of login attempts to say 3 or 5, so that in the event where there is more than 3 trials or more than 5 trials, as the case will be, and these trials are unsuccessful, whoever was trying to have access to the system gets locked out for a period of about 24 hours or 3 days until they can try again. We can also implement the captcha. Now, when we implement the captcha, with artificial intelligence around the corner, we would have to be very skillful. Else, AI is able to resolve some of these captchas. But if we pick up a captcha that's challenging to resolve, then we will not be able to dynamically resolve this on the fly, even if we use AI. One other thing to resolve the problem of password attacks, or to keep them at barest minimum, is to use multi-factor authentication. If we require that after putting in the correct password, for example, you need a second factor of authentication, maybe like a YubiKey to plug into your computer to confirm that you are the one, or you need like a one-time pad to provide from your phone that was sent by SMS or something. That further strengthens, the security. Other approaches are behavioral approaches, whereby we listen to typing patterns, because typing patterns are unique to individuals. Okay, if you listen to the typing pattern over time, you would learn the mannerism with which a particular user types. And if someone else tried to type their password, because this is very unique characteristic, they will not be able to generate the same vibrations that the correct owner of this account has. And because of that, they could get locked out. For sure, you can already begin to see some of the problems related with um, typing patterns, because imagine that uh, you got sick, for instance, and you're trying to type your password. You probably will not type at the same frequency like you normally type, and you might get locked out of your system even though you have the correct password. So all of these measures have to be taken with a lot of consideration. Another type of password attack is what we call password spraying. So with password spraying, what happens is we try to automate attempts to gain access to many different accounts or across many different accounts using common passwords. So for starters, usernames have to be harvested from breaches, for instance, and then used to compile corporate email patterns. And once corporate email patterns have been generated, then we can use predictable passwords from uh, various sources, maybe like Wikimedia's 10,000 most common passwords. We can randomly pick a password from there, and then we try this particular password with various combinations of usernames on devices on the network. Chances are that one of the accounts on this particular network might accept one of these passwords that we have chosen. Okay, so how can we possibly defend against password spraying? To defend against password spraying, we could uh, educate our users about proper password hygiene, okay, whereby we talk about good passwords that are long and that are complex, okay, but we can go as far as uh, emphasizing the need for passwords to be rotated every few months, okay, so that after a particular password has been used on the system for a set number of months, automatically the user gets prompted to change their password, if you understand what I mean. Windows has support on through Active Directory, where you can actually set up policies to permit you, to to prompt a user to change their password after a certain period of time. So you get within the policy, you set up a period of expiration for their passwords. So with credential stuffing, what happens is the attacker uses credentials that have been stolen from one breach and then tries to access other services by reusing the passwords that they have captured. So the process has some degree of resemblance with password spraying, where initially you harvest credentials, that is usernames and password pairs from a breached application or a breached site. And then you use tools like Sentry MBA to test these credentials across high value targets. These high value targets, they could be banks, they could be email providers. And once you have succeeded in logging into one of these high value targets, you can try to take advantage of exploits that these targets may be vulnerable to, and then try to, move to other devices within the network. How would you defend against password spraying and stuffing. For spraying, uh, you can try to block the top 100,000 common passwords by leveraging a tool like Have I Been Pwned. The Have I Been Pwned has an API that you could utilize within your application so that each time someone is creating a password on your system, you check to ensure that this password is not amongst the top 100,000 passwords before they get accepted. That way, if someone were to try to, utilize password spraying by utilizing this 100,000 common passwords, you would immediately know that this is not the regular user of the system, right? Because you can monitor the behavior and see this password. This is amongst the list of passwords that are, so to say, blacklisted. You can also implement geofencing and time-based lockout, where you limit the number of attempts that can be taken, the number of login attempts on an account that can happen per hour, or you can limit effectively number of login attempts that can happen per hour from certain regions. So let's say your company is based in Africa. So if someone tries to log in from Asia, from Europe, from the United States, and they try to log in with a particular username, but they keep failing because they're changing passwords, you would know that this is this is a threat to your system, and so you can shut them out. You can actually utilize a policy to implement such a thing. Okay, there is support within uh, Azure Active Directory, for instance, for such a policy. The other thing is you can try to deploy behavioral analytics, whereby you can look at the patterns of this spray, and then you can block based on recurrence of certain patterns that you've observed before. So alternatively, you can go by, blocking uh, typing patterns or password patterns that or password or patterns that are not usual. For instance, someone trying to log in from Asia, which is a little bit unusual, you can freeze that account and then rather generate an email and send to the legitimate user to find out if they are the ones that were attempted to log in. And if you were the case, you can ask them, you can prompt them to reset their password during the next login. That way, you would have stayed uh, above such an attack. For credential stuffing, you can try this by enforcing passwords that are unique. Okay, for such, you can take advantage of password managers so that you don't have to remember all the passwords. All you need to do is remember the password to the password manager itself. So as long as the password manager is carefully looked after by the organization that uh, developed it, then you might as well be secure. You can also take advantage of IP reputation databases, whereby if you find that there's attempts to log into company portals from certain IPs that have been reported as being malicious, you can, block this using a firewall. Other more universal defenses would include the usage of multi-factor authentication, the usage of passwordless authentication, or even just uh, establishing proper user education. Okay, and explaining to them exactly how such behaviors could take place. SQL injection. This is a type of attack that is not a password related attack per se. It's an attack that falls in the category of what we can call application attacks. And what the SQL attack, injection attack is an attack that tries to trick the server into, running an SQL query that is not conventional. Conventionally, when you're logging into an application, you provide a username and a password. The username and the password gets plugged in into a query statement, and all that the query statement does is it, it retains a true or false value if at least one record was retained from the database that has that username and the hash of that provided password. So the attacker is smart to understand that all you need is an SQL statement that evaluates to true. So what the attacker can do is the attacker can try to trick you by throwing at you data in the form, in the login form, that would, you know, be a part of an SQL query that renders such an SQL query to be, true. An example will be to provide a user ID of, say, 1199 or 1 is equal to 1, for instance, with dash dash at the end. The dash dash at the end, as you find here, has the tendency of commenting out the remaining part of the SQL query. That way, the bits of information up to 1 is equal to 1 will be part of the SQL query that gets generated. Because this is generated, the engine in the background would evaluate such a query, and the query will evaluate to true. Because all we needed was to have a query that evaluates to true, we would go ahead and let this attacker log in. Meanwhile, they did not even have the correct username and password. If your application does this, then we say that such an application is vulnerable to SQL injection. How do we defend against SQL injection then? Defending against SQL injection could be done in a couple of ways. One of the ways would be to do what we call input validation. What this means is that whatever the user gives as input is not taken word verbatim and thrown to the back end. So we watch the input from the user and ensure that the user's input is void of special characters like forward slash, minus minus, semicolon, colon, and so on. There's popular functions in various programming languages that can handle such task easily, whereby each time you provide input, it grabs the input, filters the input, and then plucks out these special characters before sending the rest of the input to the backend. The other thing that you can do is to use prepared statements. Now, prepared statements are essentially functions that are ready to, run. Okay, and all that these functions need are inputs. So using prepared statements, you would receive input from the user, sanitize this input and then plug it into the function, and then the function will execute the query. The smart thing that you have done in such an instance is the the input from the user, even if sanitization failed, will only be treated as variables by the function. The function will not regard them as explicit parts of the SQL query, because the SQL query is not generated in runtime. The SQL query is pre-executed, and all that is missing is the input, maybe the username and the hash of the password. So once you get this, you should be able to go ahead and run the SQL query. But the good thing is, this time around, regardless of what the attacker throws at you, this prepared statement protects you from executing it as part of the query. You can also do security audits to guard against SQL injection. And there's some more general tips, like you can set up least privilege. When you set up least privilege, basically what you're saying is in the event where someone has access to a particular resource, there is only so much that they can do with that resource. You keep that at barest minimum. You don't allow them to be able to, go past that. For example, if someone had access to a particular table in the database, they should not have administrative privileges to permit them have access to another table where they can have more meaningful information and use it against the system. You can also use a web application firewall to guard against SQL injection. Cross-site scripting attacks. Cross-site scripting attacks, what these attacks do is that they allow attackers to be able to put malicious scripts into websites that have been trusted. The aspect of putting malicious scripts into websites that have been trusted is what we refer to as injection, malicious script injection. Once these scripts are on the browser of the user, they would enable the user, the attacker, to be able to steal sensitive data or manipulate content or even perform certain actions as if these actions were performed by the user. There's a good number of different types of cross-site scripting. So cross-site scripting could be reflected, in which case we say it is non-persistent. For reflected cross-site scripting, the scripts are just reflected on the server in response to a user supplied input. So whenever there is such a thing like a search query or URL parameter, the script gets reflected. You also have stored cross-site scripting, which in this case is persistent. What happens here is that the script, unlike in the previous case, is actually stored on the server, pretty much maybe like as a record in some table in a database. And this is delivered to the user when the user accesses a page that has been affected. So it's resting on the database and just waiting for a trigger. Once you visit the page, that trigger fires and the script gets loaded from that particular table in the database, and then it's out there to execute on the website or on the victim's browser. Cross-site scripting can be potentially very damaging. It can allow for cookies to be stolen, for session tokens to be stolen, or other sensitive pieces of information. And uh, phishing attacks can also be made possible thanks to cross-site scripting. We can go as far as deploying or delivering malicious script using cross-site scripting, in which case the malware or the malicious script, the malware that gets deployed using the cross-site scripting script will now be able to execute on the user system, and then it can encrypt files, or it can gather sensitive information on the system of the user and feed this to the user that's out there on the internet. How do we prevent cross-site scripting? Couple of approaches. One is input validation and sanitation. The other approach is to have to constitute an allow list of acceptable characters, such that uh, if someone were entering a character as part of a username or a password, we check this character against the allowed set of characters. If this character is not on the allowed set of characters, we shut them out, or we signal to them through browser, as will be the case. You can highlight maybe the email address, as is the case here, to say uh, the input must contain a valid email address, or spaces are not allowed, or special characters like less than, greater than, uh, minus, minus are not allowed. Other approaches could be what we refer to as output encoding, whereby we encode data before we send it in HTML or JavaScript or other components. For such, we can use libraries like OWASP's ESAPI for encoding. We can also utilize content security policies to restrict sources of executable scripts. In such a case, we use CSV headers. We have here a buffer, and the buffer is supposed to have 8 characters at most. If we found ourselves writing 10 characters to the buffer, then we find ourselves in a situation of a buffer overflow. When we experience a buffer overflow, the remaining characters that were directed towards the buffer, they would spill over into adjacent memory locations. And when they spill over into these adjacent memory locations, they would override critical data that were in these locations. The critical data here could have been control structures within a program, like if-else statements. They could have been functions or executable code. And so when they override this, then the program that was running begins to misbehave or behaves in a manner that is unexpected. Imagine, did you know that a program actually, by simply injecting and running the attacker's own code, you can have privilege escalation, whereby the attacker abuses privileges within the system and goes from regular privileges that they should have had to root access. And if you have root access on a system, there's a lot of things that you would have access to that you would not otherwise have had access. One of the things that a buffer overflow can also result in is data theft, wherein you extract information that is sensitive and then you can store it in adjacent memory. And this will be things like passwords, this will be things like encryption keys. And if you store them in adjacent memory, this is now memory that you know its location as an attacker. And so you can access this memory as long as this information is still there and use it for various purposes. You can actually gather data, sensitive data within the system, and then since you have encryption keys in the adjacent memory, you can take these encryption keys and encrypt this data and then send it out of the network. And if someone captured this, they might not make meaning of what is happening, but you're actually exfiltrating data. You can imagine. Buffer overflows, cross-site scripting take advantage of cookies a lot of the times in their operations. So what are cookies? Cookies, these are text files that contain data that a website stores on the browser of a user when the user is interacting with this website. This is how browsers, web applications are able to remember state information when operating. These are the bits of information that would typically be contained within a cookie. There will be session IDs that are given to an application or to a user by the back end when the user effectively um, proves their identity. Okay. And throughout the rest of the time that the user is interacting through that browser, if they need a resource from that application, all they need to do is present this session ID, and then the application will validate this session ID and give them access to whatever resource they are requesting, if this resource is permitted for them to access. And so if an attacker also had access to the cookie, they would have access to this session ID, and they will be able to pretty much pretend to be the legitimate user and request resources, and these resources will be granted to them. Cookies also store information like language or theme settings. They store information like tracking information for analytics and purposes of advertisement. Have you ever thought about this? That you visit a website, you click on a particular product, you don't end up buying it anyways, and the next time you visit that same website, you already have a list of similar looking products being advertised to you. You might be thinking, is this some sort of magic? It's not magic. What's simply happening is your activity on the website has been tracked, and so based on what you did before, you are being proposed related products or products in the same category. Cookies could be of various types. You could have session cookies. Session cookies, they are used for management of a session, and they would give generally session IDs to keep you locked in across a page or across a number of pages going from tab to tab within your browser. Session cookies expire after a period of time, usually when the browser is closed. So it is good practice to close your browser from time to time when you have been interacting, with certain applications. That way, session cookies can expire. Otherwise, if someone had access to your browser because your browser has been alive all this time and they have access to your session cookies, they might be able, to visit all the sites where you have logged in or where you are currently logged in. And then they would post on these sites as if they were you. You also have what we call persistent cookies. Persistent cookies, they are cookies that are stored for a longer duration of time, and they only disappear when you actually manually delete them. Such cookies are often used for personalization and for remembering preferences during visits. Uh, you have first party cookies. These ones are created by the website that you actually visited, and they are used for core functionality like authentication. By authentication, we are referring to the aspect of proving that you are who you say you are. Okay, so when you supply your password in addition to your username, when you supply a one time part in addition to your password, all of that you're doing authentication. You also have third party cookies. Third party cookies, these are cookies that are maintained by a website other than the website that you actually visited. Okay, and these are mostly used for marketing purposes. So there's another website that is interested in your activity that probably has sort of partnership with the original website that you were visiting to be able to collect bits of information about the user and then be able to propose different varieties to the user based on the activity that they did on this website. So, how does uh, a session actually enable or facilitate uh, how does a session cookie actually facilitate you know persistence for a user on a website? So when a user, Bob for instance, tries to log into their bank, they would make a request to their bank server, and then the bank server will request their password to confirm that they are who they say they are. And after their password has been checked and this is established that this password actually belongs to them, the bank could go ahead to quiz them some more with a next challenge whereby they get, you know, uh, in the end given a one-time part, for instance, or some other second factor of authentication. Once the bank is happy with this and trust them, the bank issues a session ID and then gives it to this user. This user's session ID now resides in the browser of the user. And each time the user wants to effect a transaction on the bank, for instance, like making a fund transfer, okay, they have to provide this session ID. And when the session ID is received by the user's bank and it is verified as the ID that was given to them by the bank lets them to go ahead and to initiate the fund transfer as long as they have the funds in their account. So another type of attack would be the session hijacking, whereby the attacker tries to take control of the user's active session by acquiring the session ID that has been given to the legitimate user by the web server. In this way, the attacker is able to impersonate the user and then to access information that could be sensitive or perform other actions without needing to authenticate. Because remember, before having a session ID, the user has already been authenticated. So all that the bank does or the server does from time to time is check if this request is coming from someone that has a session ID that they know about. As long as the session ID is one that they know about, they trust such persons and then they allow them to go ahead and carry out transactions. Stealing a session ID could be done in a couple of ways. It could be done through session sniffing or predictable session tokens or through cross-site scripting or through man-in-the-middle attacks. And once the session ID has been stolen, the next logical step would be to take over the session where the attacker now uses the user session and then is able to bypass authentication and performs action as if they were the legitimate owner or the legitimate user logged in at this time. Prevention of session hijacking could take different forms. One of the forms would be to use secure cookies, whereby you set the secure attribute to ensure that cookies are transmitted only over HTTPS because HTTPS is secure. And so if any cookie is transported over HTTP, you get to reject such a cookie. Cookies that are transmitted over HTTPS are actually encrypted, and someone will not be able to intercept this communication in the middle. And even if they intercepted the communication somewhere in the middle, they have no way of figuring out what the content of the cookie is. Some other approach to fighting session hijacking is to randomize session IDs. If the session IDs are if they are randomized, then they don't have a pattern, so to say, and so the attacker cannot try to imagine what the next session ID will be. But if they were not randomized and they had a pattern, for instance, all session IDs started with AAB, and then after that there was a number, a 3-digit number, then the attacker will be able to figure out that one of these session IDs will be AAB 125, for instance, and we'll use this to pose as if they were a legitimate user. And if this session ID has actually been generated at some point, the web server will trust them as if they were logged in. Meanwhile, they are not. Another approach is to enforce um, session expiration, whereby you limit the time for which a session is alive, depending on whether there is activity going on. So if there is inactivity for a certain period, so you set a threshold such that if there is inactivity for the period equivalent to that threshold, automatically the session expires. That way, even if someone had access to such a session ID, they will not be able to do some activity on the website. Other approaches would be to add extra layers of security beyond session IDs by requiring that there should be multi-factor authentication. And then a more rudimentary approach would be to regularly inspect uh, activity to figure out if there is suspicion activity that's going on. And for such kind of activity, we can make use of intrusion detection systems. Open Web Application Security Project, it often goes by the acronym OWASP. And a lot of times you would hear of OWASP Top 10. OWASP Top 10 is a recognized standard widely that seeks to identify most critical web application security vulnerabilities that are out there on the internet. This project is an ongoing project that constantly ranks vulnerabilities as a function of their prevalence. So there's a database that maintains the types of vulnerabilities that have been reported rampantly by various applications out there on the internet. And these vulnerabilities are ranked such that the top 10 most prevalent ones get singled out by OWASP and then put out there for the users. And each of these for each of these top 10 vulnerabilities, you are told the name of the vulnerability, the way it operates, and common ways that you can defend against this. This is good information to educate developers about these vulnerabilities. And it is useful because it kind of provides a baseline for security testing during development. So during development, you know for a fact that you would have at least 10 vulnerabilities to test your website against before you can push it out there. So if you test against these 10 vulnerabilities and your website comes out on the top, then you are happy to push it into production. Otherwise, you send it back for the developers to rework to close up these vulnerability gaps, and then you can send it out anew for testing. Application security has to do with secure development practices. Here, one of the things you might want to do is to implement coding standards that are secure such that you can keep vulnerabilities at the barest minimum during the development phase of the application. The approach that is favored here is to shift security to the left. What this means is that we try to prioritize identifying security risk early in the software development lifecycle. Application security testing has three common forms. One of the forms is what we call static application security testing, or SAST. In SAST, we analyze the source code for vulnerabilities just before it is the code gets deployed. So we write the code, we finish the code, we test it that the code is working, and then we pass it through the SAST processes to be sure that the code is ready to be sent into production. You also have the dynamic application security testing, whereby you test the application continuously during runtime to identify exploitable flaws. So it's possible that from the moment that an application leaves development and then goes into production for use, it could pick up vulnerabilities. So you don't want to leave that to chance. So while it is in use, you want to execute it at runtime to identify any faults that are exploitable and then be able to fix that. You also have the interactive application security testing, IAST, that combines both SAST and DAST. Other other approaches to application security are to leverage access control and authentication. One of the things that you can do is to make sure that you have robust authentication mechanisms like multi-factor authentication. Some other thing that you could do would be to implement role-based access controls to ensure that permissions are given based on the roles that users have within an application, so that a manager will be given manager managerial related permissions to operate within a system, while someone in HR will be given just HR related permissions. In this way, someone within IT will not have permissions to be able to take a look at payroll and make modifications. And someone within HR will not have the permissions to be able to take a look at the code base and then to modify the code. Another approach to application security would be to enforce encryption and data protection. With encryption, we encrypt sensitive data either at rest or in transit. For data in transit, we can use transport layer security to encrypt data and send. And for data at rest, we can use strong cryptographic methods that would vary depending on the environment in which we find ourselves. For example, for data at rest, you can take advantage of AES algorithms, AES backed algorithms to encrypt this data. Lastly, to enforce application security, we can take on monitoring and logging. When applications run and logging has been configured, the applications are able to generate logs about what they are doing, and these logs could also include instances when these applications were launched, when they were stopped, and when they failed. That way you can track the behavior and then figure out where something might have gotten wrong. Imagine that there was an application that was running, and then all of a sudden the application broke down. And later on, you realize that on a set day there was a breach in the company. If you try to put these bits together, you might realize that the moment the application stopped running, it did write a log to specify the exact time at which it stopped working. And if you check this, it might fall in the same time span or time frame during which your company experienced a breach. Having these two bits of information put together could really be useful to inform you on next steps to take. If it has to do with backing up or restoration, you know that you will be interested in any information that might have been missing from the point that this application stopped working. Okay, so if you had backups, you can compare the backups that you had with the information that ends up in the system, and then you would see the divergence from the point where the application stopped working, and then you can figure out what the perpetrators of this breach might have been interested on might have been interested in with regards to your system. Now, here are some very good practices that you can adopt to ensure that your application security is optimized. One of these approaches is patch management. With patch management, the interest here is to ensure that you update applications regularly so that components that were faulty and components that were vulnerable can get fixed each time a patch has been released. You can also make use of web application firewalls to protect against common threats like SQL injection or cross-site scripting. And you can also implement secure application programming interfaces, APIs, where you use authentication tokens, rate limiting, and input validation to validate for application programming interface security. One other thing is to try to integrate security into every stage of the software development lifecycle. When you find yourself implementing security, even when you are doing analysis, when you are doing design, we say that you have implemented the concept of shifting security to the left. Shifting security to the left is the principle around which DevSecOps is built. You can also consider establishing a configuration baseline by accepting on certain minimal configuration standards that should be followed for every application in your system. If you were to adopt such, then chances are that at all points you would have a minimal amount or degree of security on your systems.